This recording is to help you with lesson 9.04 on mathematical induction. Okay. For mathematical induction, there are always a couple steps that we need to follow. This really isn't mathematical induction quite yet, but it is getting you in the process ready for it and thinking about it. We need to find p of k plus 1 if we're given p of k. So basically what it means is anywhere that I have a k, I'm going to substitute in the k plus 1. So I will now get your k plus 1 squared, because this is where I had a k, parentheses k plus 1 squared all over 4. Okay, and then you can simplify this right in here. This is k plus 2 squared all over 4. Okay, so it's kind of getting you in the frame of mind to get started on your mathematical induction. Okay, and a mathematical induction is just a proof to show that something works. Okay, so here we have a formula, and we need to use mathematical induction to prove that it is true. So the very first step is plugging 1 in for n and seeing to make sure you get your very first term. So if I plug 1 in for n, let's make sure we get 2. Well, 1 plus 1 is 2. 2 times 1, in fact, is 2. So that works out okay. So we show it works for n equaling 1. Then we're going to assume that it works if we plug k in. So I can list this all, and instead of saying n, I'm going to put a k in there. Okay, so that's step 2. We substitute k in for n. Here's the tricky part then, step 3. We are going to then show that we can take this part right here, so far, so the 2 plus 4 plus those and 4s, all the way to 2k. Now we're going to add on the 2, and we insert that k plus 1. So right now we have all of this plus your additional 2 times your k plus 1. And we want to show that that actually equals your k plus 1 times k plus 1 plus 1. So here I just added to it on the left-hand side. On the right-hand side, I'm using substitution. I'm plugging k plus 1 in for k. So my goal is to show that these two sides actually are, in fact, equal to each other. That's my end goal. Okay. Well, I know from here to here that that equals this. So I'm going to use substitution again and say, well, I can replace that with k times k plus 1 plus 2 times k plus 1. Now from here, I'm going to kind of just simplify my second parentheses on the right-hand side. Obviously, that's k plus 2. I'm almost done. I can look at this as factor by grouping, almost. Okay? They have a k plus 1 in common, so we take what we factored out. So if we look at it like factor by grouping, we get that k plus 2 times k plus 1. And now we just showed that those two sides are in fact equal to each other. Okay, we got equal statements here. So mathematical induction does prove that that's a true equation up there, a true formula. Let's look at another one. The very first step is showing that it works when you plug in 1. Okay, so if I substitute 1 in for here, we get 2 to the first power minus 1. So that's 2 minus 1 equals 1. That is, in fact, the very first term. So that works out okay. Step 2. You are then going to rewrite everything and replace n with k. So that was step 2. Step 3 is your tricky part. Okay? I'm going to take everything that I have so far. So 1 plus 2 plus everything up to 2 to the k minus 1. And now I'm going to add on that k plus 1 for the insert the k there. On the right-hand side, I'm substituting in the 2 to the k plus 1. Okay, let's use some substitution here because we want to show that these two sides in fact are equal to each other. So from here all the way to here, I know that that is equivalent to the 2 to the k minus 1. All right, and then I just simplified that exponent, so it's just 2 to the k. And now I want to show that these two sides, in fact, are equal to each other. All right, and now I'm going to try to simplify this. I have 2 to the k minus 1. I'm kind of running out of room here, so maybe I can kind of bring things up a little. We're trying to get that so it's a k plus 1. Let's see if we can remember any of our rules. Kind of drawing a blank here, but I do know that it works with turning to that. I'll look and see if I can figure out which logarithmic property or natural log property or some type of property allows me to rewrite that as 2 to the k plus 1 when I have two of the same thing. Okay. Either way, though, that last step there is what we needed to show that they were actually equal to each other. So I'm going to search for this property here that allows me to do that. All I know is that we can, in fact, do that to show that those two sides are equal to each other. I don't believe you're going to run into anything quite that tricky with your homework. If you do, let me know. I'd be happy to go over that with you. Okay, and then the last one, it says find the sum using the formulas for the sums of powers of integers. All right, and this was taken directly from the lesson, so let me just copy and paste that real quick for you. It's the magic of technology here. I was able to copy and paste these sums for you. And since we are looking at the fourth power, we are going to turn to this formula right here, where n in this case is 5, because that's how many terms there are from 1 to 5. So n in our case is 5. So when we substitute 5 in and simplify, we should get 979.